Hello, Namaste. I am Ramesh Puri from Udaipur, Gaigat. Uh, the I have prepared some slides which is given in the final examination questions paper. So I am going to present these answers from this presentation. The presentation goes like this. Here, Geometry and Modeling, Ramesh Puri, exam roll number 7715521028. The first question is here. What do you mean by cycloid and trochoid? Cycloid and trochoid. Illustrate with examples. So here, cycloid. I am going to explain about the cycloid. A cycloid is a curve generated by a point P on the circumference of a circle which moves along a straight line without slipping. For example, cycloid curves are used in the design of gear tooth profiles. Here in the figure also, this is the circle which rolls in a straight line and forms a curve. This curve is called cycloid. Next one, trochoid. Trochoid is also the curve traced by a point which is fixed on a circle as it rolls along a straight line. Here in the figure also, here in second figure, this is the circle and the fixed point here which rolls along a straight line. Then after rolling, it makes a curve, which curve is called trochoid. For example, if you walking regularly along a blackboard, holding a chalk stick in your hand with a regular circular motion, then you are tracing a trochoid. First question, number A here, and then use MATLAB to graph the given cycloid and trochoid together on the interval 0 to 4 pi. The I have shown here this figure explain about this trochoid, which is 0 to 4 pi from the MATLAB. And next question here, find the coordinates of the 4 points of intersection by using MATLAB. Trochoid and cycloid equation is given here. For these questions, answer here. At first, define the t, which is from 0 to 4 pi, and then after plotting, then hold on these figures here. Here all explanation here. They are random. In means here t and u are the variables which defined here. Then these 4 points, 1 2 3 4 points which intersected this trochoid and cycloid. Here trochoid and cycloid colored in different red and blue. So this is given here. And next one, number B, define epicycloid with example. Epicycloid with example. For this question, the answer is here. Epicycloid is a plane curve produced by tracing the path of a chosen point on the circumference of a circle which rolls without slipping around a fixed circle. For example, epicycloid well. Epicycloid is a plane curve produced by tracing the path of a chosen point. Here is example epicycloid well. And circumference of a circle which rolls without slipping around a fixed circle. Here is fixed circle. Yes, on these questions still yeah. And then one illustrate with example also given here. I have given here. And use MATLAB to graph the given cycloid and trochoid. No, this is not this question. Second, illustrate the formulation of epicycloid in MATLAB. How the epicycloid is formed. For these questions, answer here. Epicycloid is formed like form k is equal to 6 suppose, and then t is equal to 0 to 2 pi, and x is equal to the parametric equation of the epicycloid is cos t minus k plus 1 cos t minus k. Here if a is k and b is 1, if you suppose this, or you can say a plus b into cos t minus cos a plus b into t, and similarly y a plus b into sin t minus sin a plus b into t. This is the parametric equation. So by plotting this parametric equation, we see here figure and figure, these figures, which is the epicycloid. This is formed from the math lab. And next one is, consider a circle radius is greater than 0, roll around the second circle with radius is greater than 0 outside of the first circle without slipping, and find the epicycloid formed by the curve tracing by a circumference of a rolling a circle. Epicycloid formed by curve, and find parametric equation of, and another is given question, graph the epicycloid at least 3 value. So all these questions answer here. The parametric equation of this is here r plus capital R cos theta. We can say in this way also, upon theta by r, and y is equal to r plus capital R sin theta minus r sin r plus theta r plus capital R theta by r, where r is the radius of a rolling and r that of the fixed circle, and theta is the angle between the radius vector of the point of contact of the circle. This station here. I first define the variable a b real, assume a is greater than 0, b is greater than 0, then put the parametric equation r is equal to a plus b cos t minus b into cos a plus b into t by b. Similarly, a plus b minus in this way, plotting this, and r1 r2 r3 defines of this, r plot r1, f plot r1 r2 and f plot in this way. Then after that, back length, which is, and then velocity after then speed acceleration in this way beta, and then curvatures shift by, we can see. So in this way, I have written in the word also. Number second, answer this one. Find the parametric equation, the episode formed by the trace out of the circumference here given. First one this, and then second one, find the parametric equation of the episode. Here is the parametric equation, where is radians rolling. Graph the episode at least 3 values of r and s, which is given here, at least 3 value, 3 types of, and compute speeds and curvature. Speed and curvature is computed here. Then specialize the case where r is equal to 3 and s is equal to 1. Use different color to represent circle, epicycloid and evolute. Here given epicycloid and evolute all are given here. This was here also written here, cycloid, trochoid and epicycloid. Okay, in this way my first questions, which is here part A and part B, about cycloid, trochoid and epicycloid. I have completed in slide also, in insert sheet also. So epicycloid, cycloid and trochoid. Here speed curvature of the cycloid also given here, and then figure also. The parametric equation of epicycloid is here also given, a plus b into cos t minus b into cos a plus b into t by b. This is x, and similarly y, a plus b into sin t minus b into sin a plus b into t by b. This much, it is all given here. Okay, in this way first part and second part I have completed. Thank you.